Hi guys out there. Hope you're ready today to work on maths. Okay, my name is Rakubu. Today guys, we'll be focusing on the central tendency in statistics. Okay, remember when you do your mathematics, you don't just observe, you need a pen and paper to try some of the problem. That's how actually you do your mathematics. Okay, we don't read. Okay, we do problems. Okay, but I'll be going through some of the concept with you today. Okay, so let's look at what we have for today. So into the central measure of central tendency. Before we do that, I have a question for you. Why was the second wave of COVID-19 declared, and based on what? The second wave, what do I mean when I say second wave? Okay, when the COVID started, and we reached a peak. The peak implies the maximum, where we're recording about 13,000 daily infection per day on average, okay? And we started with like 23 cases, then we moved to 13,000. Then that 13,000 cases went into 9,000, then started decreasing into 1,000. Decreases to 500. Then the first wave of the COVID-19 was complete in a way. We're actually on level 3 lockdown. Then the second wave was declared. Based on what? Using data. Why was the second wave declared? Because the daily infection of the COVID-19 was into 8,000. So the moving average, the average on 7 days was more of 8,000, 9,000. Hence the second wave was declared. Do you think the second wave will be higher than the first wave? What does that mean? Does it mean, are we going to get more than 13,000 COVID-19 in the second wave? Will we have the third wave? Is that possible? Can we really predict that using data or by looking at data? Okay, so that's important data. It's an interesting question. I hope you thought about it and you're aware about this. Fantastic. So there's another question for you. Do you accept any claim or argument without data? If someone comes, say, there's an argument, do you accept it without data? I think we should question things. If we have data in front of us, it's better to accept an argument because someone will be presenting some evidence, okay, that this is what is happening. There's evidence that we are in second wave. Hence, probably more restrictions, if we believe that. Okay, fantastic. So I wouldn't accept with anything without data. Now, we're going to look at what do you call estimated mean of the data. After that, we'll look at something called the quartiles. Okay. Then we'll look at mean. After mean, we'll look at the median. Median, we'll look at the mode. Okay. So let's look at some of the keywords. What is central tendency? Okay. Central tendency, I mean, it's a random variable, okay, which tends towards mean, median, and mode. Mean is the average. Median, if we arrange data from the smallest to the highest, the middle one is the median. And mode is the most occurring. Okay? So I want you to go and think during the pandemic, how many people, go and find the mode, how many people got affected by COVID-19? You might find the mode. People under the age of 2, elderly, people between 30 and 40. If people between 30 and 40 are the highest with COVID-19, that will be the modal class. Okay, you can find that for yourself. So what about the extreme value? So the extreme value can either be the minimum or the maximum. Those are the extreme. We do notice extreme value in a way, okay? And when we notice extreme value, we act on that, okay? With respect to the COVID-19, there's been some extreme values in some provinces. When they do the test, they say, okay, this province, they're getting more positive case, then hence more restrictions. Those were extreme values. So the extreme value can be the highest or the minimum. But if you look at the COVID, if you want to stay on the cautious side, you look at the highest value where you have more positive cases and more restriction we impose in other provinces. So it's important that we know extreme values if we have data set, the lowest and the highest. Okay, fantastic. So now we're going to some of the keywords, frequency table and tallies. Okay, frequency table is if we can group data using age from 0 to 19, and the tallies will be how many, if we count how many people between 0 and 19, and the frequency will be the total in that category. Okay, does that make sense? Okay, so the frequency will be the total tally for that set of an interval. Okay, so the tallies and frequency, they're going hand to hand together. Now, we have estimated mean, quartiles, mean, median, mode. We're going to look at mean. Okay, so let's look at this, the mean. So the mean is what is commonly known to tend to think as the average. The mean or the average of the data is the sum of the data divided by the total number value of the data. Does that make sense? So that's the mean. Okay. So another way you can think of the mean, if you, let's say how many people affected with COVID in South Africa. I mean, if you look at the average, it can be based on tests, how many tests were conducted and how many people with positive cases. That's another way you can look at that. Okay. So in mathematics, if I put in formula, the mean will be the sum of all x value of all the observed variable over the total values of x. So this is called sigma. That science means sum, adding all the x's, and is over the total, the observation, how many values you have. Okay, let's look at an example. 2 dice were thrown 10 times, and their score were added together and recorded. Find the mean and the range for this data. Okay, so we rolled a die, we rolled 2 dice, so we get 7. So the first die could have been 6, and the second die could have been 1, which is 7. And the second observation is 5. That could have been 1. 4 and 1, or 3 and 2. We don't know, okay? But we have the data with us. Then the second observation is 2, then 7, 6, 12, 10, 4, 8, 9, which is our 10th observation. How do we calculate the mean? We have to add everything divided. We have to add all this divided by how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see how we do this. So we have to add 7, 5, 2, 7 again, 6, 12, 10, 4, 8, 7, over 10, because we roll the 2 dice 10 times. Okay? Then what do we get? Let's see what we get. We get 70 over 10, then the average is 10. Okay. What does an average mean? Okay. Let's say you go to your maths class and you calculate the average for your maths class, and the average is 50%. What does 50% mean? Does it mean everyone in the class get 50%? Not necessary. Okay. You could have someone with 90. Okay. You could have someone with 10, 20, and so on. Okay. Just the combination of everyone divided by 10, you're getting 50%. Okay. Now, what is the range? So the range is actually the maximum minus the minimum value. So what is the maximum value here? So the maximum value is 9. The maximum value, is 12. So this would be 12. And what is the minimum? The minimum is the smallest, which is 2, which is 10. So this is the maximum minus the minimum value, which is the range. What does the range tell us? Think about this. What does the range tell us? So the highest minus the lowest. Okay? So usually a smaller range, if you compare two sets of data, will mean kind of consistency. And a bigger range, smaller consistency. Okay? Because the highest value minus the smaller, there's a gap between the two. Okay? So in South Africa, we'll look at, in terms of inequality in this country, if we calculate the highest, the person who earned the most, and the lowest, there's a huge deviation. There's a gap between the person who earns the minimum and the person who earns the highest in our country, okay, which causes lots of inequalities based on data. Okay, so data is very important. Okay, guys, so bye for now. See you after the break, and we'll continue with more statistics, data handling, and look at the central tendency. Beautiful.